So now that we've looked in some detail at multiplying polynomials, let's take a look at dividing. So I know I mentioned this rule in the last section where we have a division. What we do is we subtract the exponents. So here, I'm going to subtract 14 from 20, and I end up with x to the 6th. What about here where I have an exponent on a fraction? So because that exponent is applied to the whole fraction, I'm going to go ahead and distribute it to the numerator and the denominator. Power to a power, remember I multiply, and 2 cubed is 8. Okay, so here I have an exponent on a fraction. So go ahead and distribute that top and bottom. Let me distribute that 4 to all 3 factors. And then here, power to a power, so q to the 12th. And then let's see, anything else I can do? I guess I can make 2 to the 4th into 16. Let's see, I think this is a negative. Okay, so I distribute my 4. Oops. To the top and the bottom. Let's see, so do you remember how this numerator works? It's like there's an implied 1 there. So I can actually distribute that 4 then. So what I arrive at, let's see, I have negative 1 to the 4th, x to the 5th to the 4th. And then power to a power, so multiply y to the 28th. Okay, negative 1 to an even power is positive 1, x to the 20th. So x to the 20th over y to the 28th. Let's see, these guys, these are both zeros. So here's another rule, we've mentioned this one. X to the 0 is defined to be 1. So remember here, this is like I have negative 1 times this quantity. So that means I follow my order of operations. Remember that was the PEMDAS, right? That means I have to do the exponent before the multiplication. So 2/5 to the 0 is 1. And then same thing here. I do 3 to the 0. 3 to the 0 is 1. Then I can do my addition. Okay, now that exponent's only on the y factor. Turns into a 1. It's an easy one. Oh, here's another rule. I think we mentioned this one before too. But if I have x to the negative m, the negative flips the fraction. That becomes 1 over x to the positive m. So 5 to the negative 2 is 1 over 5 to the second. So 1 over 25. Okay, so notice only the x is under the exponent. So x to the negative 3 is 1 over x cubed. Then I can multiply straight across. Okay, so what about something like this? So what to do first? Maybe I'll go ahead and make that r to the 0 into a 1. Need more room. Let's see, negative 5, 1 t to the negative 5. So 13 r to the 8th t cubed over negative 5 t to the negative 5th. So let's see, I'll have negative 13 fifths. It's looking at these. And then r to the 8th, there's only that one r to deal with. The t's, though, I have to take that 3 and subtract negative 5. That's looking at these. So, t to the 8th. I could write it like so, or if I wanted to, I mean, this is over 1. So I could also write these guys in the numerator and the 5 in the denominator. Either one. Okay, let's look at the constants. 30 over 15 is 2. Let's look at the a's. A over a to the negative 1. So I have a to the 1 then, right? So that's a to the 1 minus negative 1. And then b's. B to the negative 4 minus 2. So that's a to the second times b to the negative 2. 1 plus 1 is 2, negative 4 plus 2 is negative 2. So then if I wanted to make this into a fraction, let's see. The b to the negative 2 becomes 1 over b squared. Then I can multiply straight across. And there we have a nice answer. Okay, here this exponent is on the whole expression. So that means that whole expression goes under a 1, and then that exponent turns positive. Then I go ahead and distribute the exponent to all 3 of those factors, right? 5 squared, 25, x to the negative 8, y to the 6th. Now what to do with this negative power? That flips the fraction. So that item that has the negative exponent, that factor, it's going to change position. So if it were in the top, it would move to the bottom. But since it's in the bottom, it actually moves to the top. Okay, interesting. Let's see. 24 divided by 4 is what? 6? And then m to the 2 minus 3? That factor is going to distribute, so I'll have 2m to the 5th plus 5, and then I add, right? So it's 3 plus -1. Okay, looks good. So 6. 2 plus 3 is 5. Have some like terms there then. And then m to the 3 minus 1, 2. So I can combine my m to the 5th, so there are 4 of those. And that's about it. Oh, and that's the last one.